All right, let's go ahead and begin our tutorial. The first thing that we are going to look at is the print function. Now, we will talk about what functions are, and very soon we will create functions. But let's go ahead and write this line of code. So you want to say print, and then you have a pair of parentheses, and in between the parentheses, you want to put two quotation marks and write hello world. This is what a function does. It takes an input, does some process, and then returns an output. Now let's see what this particular function does. So I'm going to go and save this file. To save the file, you can either go to File and choose Save, or you can use the shortcut Command S on the Mac. On Windows, it will be Control S. So I'm going to go ahead and hit the play button. Now, if you don't see the play button here, you may have to set up your Python interpreter. So I'm going to click on Play Now. And you can see what has just happened. In here, I wrote a small message, hello world. And that very same message is now appearing here in the integrated terminal. Okay, the equivalent of this would be the command prompt on Windows. Let's change this and type something else. For example, good morning. Save that, hit the play button. So what's the print function doing? So we said a function will take some input, do some internal process, and then return an output. Well, in the case of the Python print function, your input will be some message. What the Python will then do is talk to the operating system and pass your message onto the operating system, which you can then see here in the terminal. Why have we started with the print function, and why is this even useful? What does a print function do? The print function takes in the message that you have typed in here, and it outputs it here in the terminal. So this is one way you can evaluate your code. Now, this is a very simple example. We can't really appreciate print at this point. So what we want to do here is make sure our code is actually working. We have the correct environment set up before we, go any further. Okay? So the reason we're starting with this exercise, the reason we are starting with this built-in function called print, is to make sure our environment is actually set up. And we can see that it is. Okay? Let's look at this from a different angle. Say you are going to write an algorithm with 5, 10, maybe 20 lines of code or more. And to create an algorithm with that many lines, you need to track your process, track your progress, I should say. You see, when you have a complex algorithm with, let's say, 10 lines of code, the code could break in any particular line. And how would you find out what line is causing that problem? Now, there is something called debugging in the practice of, programming. But part of debugging is printing the output at any given line. So the reason the print function is going to be your friend is because this will grab, this print function can grab some message at any point inside your algorithm and print it in the terminal so you can see the result. Now, we call this value that we have passed in between these parentheses a string. And a string is a sequence of alphanumeric characters. Okay? So what do we mean by alphanumeric characters? I'm just going to open a tab here just to make an example, and I'll come back to this tab again. So if you want to say the day is, for example, January 1, 2020, well, you can see here we have a sequence of alphanumeric characters. That's an alphabet, that's a letter, that's a letter, that's a letter, that's a space. That's another letter, and if we keep on going, then we have a number. And then we have a comma, that's a special character. So we call this sequence of alphanumeric characters a string. And in programming language, if you want to indicate that you have a string or you want to create data that contains a sequence of alphanumeric characters, you would do that by including either double quotation marks, single quotation marks, and some programming languages will even allow the tilde or the grave accent. Okay, but we will stick to either the double quotation mark or the single quotation mark. And they are interchangeable. So it doesn't matter if you use double quotation or single quotation. But this detail is very important. The quotation marks are very important. Because if you don't include them, so watch this. If I were to remove the quotation marks, the Python is going to throw an error. Okay? It says invalid syntax. Now we'll see why it says that. But for the time being, let's just make sure that whenever you want to have a message, if you ever want to write a sequence of alphanumeric characters, you must start that sequence with quotation marks. Okay. Now the print function will come in handy when you're debugging your code. Or if you want to observe the behavior of your algorithm. Now we haven't started with algorithms yet, but this little function will come in handy very soon. Okay, let me comment this out. Now this is how you comment out a line of code. When you put an ampersand in here, this tells Python to ignore or not to process this. So you see in a Python file, and this is true for other programming languages, you can use comments to explain what a particular line of code is doing. So over here, I can say here, section 1, built-in functions. Okay. I can type in here whatever I want. And then I can uncomment this. And, well, I can add lines explaining what I'm doing here, right? Looking at basic examples in Python. Okay. I can section them, and then, well, once this file gets very big, these comments will help me navigate, my way around the file, and I can know what each line of code is doing. So comments will be especially helpful, once you have a program that's quite complex. Okay, although it even helps to have comments even if you have simple programs. All right, now let's look at the input function. So I'm going to comment this out, and let's look at another built-in function. Okay, this will be the input function. And here I will type in, what is your name? Now, if you notice here, I've put a question mark in here. And I'll show you why I've done that. I'm going to go ahead and hit play. Okay. Clear my console. And right now the process is running. Okay. If you notice here, we have this placeholder for the user to respond. So this process is right now on line number 6. And it will not terminate, it will not exit this process until we have responded to this question. So the reason I put that extra space in here is to make room for the user to respond. I'm going to type in my name now, and as soon as I hit enter, the process will terminate. What's the point of this exercise? If you remember, we talked about the three components of a computer. We said we have a processing unit, a permanent storage, and a temporary storage. And what was the purpose of temporary storage? To save data. To save the data that is generated by the program. We said that when we have a program, it turns into a process. And as long as that process is running, space from temporary storage will be allocated to that process. So whenever I hit play here in VS Code, my program will turn into a process, and I will be taking some space. I will be consuming some space in temporary storage. Let's run that again. Okay. I will now respond to the question. And just to make it especially clear, the reason I have this space in here is so that when I hit run, the response doesn't get, the response doesn't stick to the question mark. That's really the reason why I've put the question mark in there. Okay. So let me put that space back in here. Hit play. Respond to the question. Now the process has exited. Now, what happened to this answer? When I typed in my name and hit enter, where did this value, this string, go? Well, it went into temporary storage. When you type in a value and hit enter, that data that you have just written, that data that you have just typed, will be put into temporary storage. Now, the reason I've shown you this example is to now introduce you to the concept of a variable. So let's write the following code. Username equals input. If you notice here, I've used an uppercase N. Now, this is a special programming convention. It's called camel case, and I'll come to it in a moment. But let me tell you what this line is doing. Here we're using the input function to prompt the user for input. How will the user know what it is that we ask them to do? Well, this string message, right? The string contains the message. It tells them what is your name, and when the user sees this, they will know how to respond. And the user will in fact respond, right? They will type in the response in the terminal like I just did a moment ago. Okay. And this value we said will be stored, this piece of data will be stored in temporary storage. Well, what did we say we know about temporary storage? Data that is stored in memory will have an address associated with it. So we know where a piece of data is stored. And if we know the address, we can get it back. That's what a variable is. A variable is something that points to the address of some data in memory. And we can use variables to get back that piece of data. So let me bring back here the print function. And here I will say user name. Okay. So we have a tiny program with 2 lines of code. And let's see what this will do. First, the input function will run, which will present this message in the terminal. The user will then respond to this message. That message, that piece of data, will then be written to temporary storage. And this variable will then be assigned to that value. This variable will be assigned, that data in temporary storage will be assigned to this variable. So we can, using variables, we can always get them back. The reason a variable is called so is because the variables can point to different values in temporary storage. Variables can point to different pieces of data in temporary storage. We will look at an example of this in a moment. Okay? But once the user responds, we will assign their response to this variable, and then using the print function, we will get it back. And this will help us find out what the user responded with. I'm going to hit play now. It's going to ask me, what is your name? I'll type in my name. And as soon as I hit enter, my name will be stored in temporary storage. But then using the print function and the variable, I can pull that piece of data from memory and print it here in the terminal. And just to be clear, if I remove the print function and I leave the username out here, yes, this will retrieve the user's name from temporary storage. But when the user responds, or when I respond, we won't see the value of the variable in memory. Okay, so that's the reason we have the print function. Okay, you want to tell Python, retrieve the value that was assigned to this variable and then print it, so we can see it in the terminal. All right. Now, before we start our first exercise, let me tell you a little more about variables. There are certain rules that apply when you want to create a variable. Now, you can call a variable whatever you want. I didn't have to call this username. I could have called this XYZ if I wanted, ABC if I wanted. The name really doesn't matter. So you can create a variable and call it whatever you want, but there are some restrictions. There are some rules that you need to follow. Let's talk about the rules a little bit. And here I'm going to add a new section. Number 2, call it variables. Okay. So let's scroll down to section 2. Talk about the rules for declaring variables. And let's comment these. We'll come back to them later. Rule number 1. You can call a variable whatever you want, but you cannot name variables after reserved keywords. What do I mean? So you can create a variable, for example, my name. Let's just use camel case here. Okay. Now let's create another one. The price. It's just some random, value. Okay. That's a string. That's a number. We will talk about strings and numbers in more detail. But let's just focus on variables. So you can call a variable whatever you want. But what you cannot do is name a variable after a reserved keyword. So for example, you can't say print equals, something. Why? Because print refers to a built-in function, right? We just looked at it in section 1. You can't say input because Python has used these names. And so you cannot override them. That's rule number 1. Rule number 2, variables must begin with lowercase letters. Okay, must begin with a lowercase letter. Now I'll tell you why you must begin with a lowercase letter. Using uppercase letters are reserved for something we call classes, which we'll get to in a moment. But you must begin, you can only begin a variable name with a lowercase letter. Now, other programming languages you can even use an underscore, but underscore characters, that's an underscore, have a special meaning in Python, so we don't even want to use underscore letters. Now, where and why we would use an underscore character, we'll come to, and we will answer that later on. Okay. So when you create a variable, for example, the price, you want to make sure the first letter is all lowercase. If you use an uppercase letter, this convention of starting a variable name with an uppercase letter indicates that it's a class. So while Python will not break your code, so you can actually do this, all right? You can say print the price, and you can treat this like a normal variable, and everything will work fine. But in the programming world, it is a widely established convention that class names start with an uppercase letter only. So if you use an uppercase letter, you're kind of going against this convention. And while that may not cause your program to break, it can create confusion. Confusion for yourself and definitely for others who may look at your code. Okay? So this is more of a suggestion than it is a Python rule. But you must, even if we were to use an uppercase letter, which you do not want to do, it must be a letter. So you cannot, for example, start a variable name with a number. So you can't put 1 in here, for example, or a question mark. Okay, the only allowed character is a letter, and the convention is to use a lowercase letter. Rule number 3, and this is more of a naming convention. It's a suggestion than it is a rule, but conventions, if they are followed, can be very helpful. They can reduce the number of defects in the code. But for rule number 3, we will say you want to use either camel case notation or snake case notation. Let's look at examples to understand what do we mean by camel case and what do we mean by snake case. Okay, which brings us to step number 4. Now I'll show you an example of step number 3, but before I do, let's also point out rule number 4, where it says that no special characters except underscore. So you cannot use special characters anywhere in a variable except underscore. Okay? So let's look at examples for both rules 3 and 4. If you remember up here, we used the example of the username, right? So let's type it back again. So username. Username, and again, username. Are these variables the same? They are not. They have they can be read the same way, but they are using different characters. This one is using an uppercase letter. This one is separated by an underscore. So as far as Python is concerned, these are 3 distinct variables. Yes, they have the same value, but they are 3 different things. In programming, letter casing is very important. In Python, spacing is also important. Spacing is very important in Python. Now we'll get to that momentarily. But remember, when you are programming, you want to be super strict. The more strict you are, the less frequent the defects. Okay. Rules number 3 and 4. Now, the first one is not using any particular naming convention. So we have the words username, right? Our variable name is composed of two words. And we're not separating these two words by any delimiter. And we actually cannot, unless we use an underscore. So what do I mean by delimiter? So for example, you cannot put a space in here to separate these two words, right? When you put a space in here, that tells Python that you have a it could be a new statement, or it can be another it could be well, it doesn't make any sense to Python what we're doing here. So you cannot put any space inside a variable name. You can't use a dash either, or any special character for that matter, except underscore. Okay? So you can't use any special characters except underscore, and you can also put an underscore, by the way, anywhere you want. You can put the underscore at the end. You can put the underscore at the beginning, although putting underscores at the beginning or end of the Python, at the end of a variable, have special meaning. In Python, using underscores at the start or at the end have special meaning. So avoid using underscores at the beginning or the end unless, well, you know what you're doing. Okay? Now we'll talk about putting underscores at the beginning and the end once we get to classes, but for now, let's stick to rules for naming variables, and that is you cannot use special characters to separate. You cannot use special characters as a delimiter except for the underscore. Now, when you do use an underscore, like this one down here, when you use an underscore, this is called snake notation. This one down here, however, is called camel case. And if you look at it, maybe you can figure out why it's called camel case. It's called camel case because every first letter of a subsequent word is capitalized. So let me show you another variable to just exaggerate and make it especially clear. So here we can use the customer first name. Okay, so the first letter of the first word must be lowercase because that's rule number 2. But the first letter of every subsequent word must be capitalized if you're using camel case notation. So C is the start of the second, customer is the second word, first is the third word, and name is the fourth word. And you can see, we can tell we have 4 words because the first letter of every subsequent word has been capitalized. Now, generally, camel case notation is more popular in programming, but snake case is actually more popular in Python. Okay, so both of these are acceptable, okay, because, well, simply they're easier to read than not using any particular notation. Okay, so you are free to use either one of these. Now, since snake case is more popular in Python, I will try to stick to this convention. Okay? Let's add some comments in here. This is no naming convention. This is snake case convention. And camel case convention. All right. With these two things in mind, let's go ahead and look at our first exercise. So this is the first exercise. What you want to do is use the input function to register the user's details. And their details are first name, last name, email, and phone. And then you want to use the print function to confirm their details. So now you can pause the video, work on the exercise, and then resume the video to look at the solution. All right, so here's the first. All right, so let's look at the first exercise. You want to use the input function to register the user's details. If you remember, in example 1, we use the input function to ask the user's name. Okay, we said that the answer will be put into temporary storage, and then we can use the print function together with a variable to retrieve the value from temporary storage and then print it in the terminal. We want to do the same thing in here. But this time, we don't want to just ask the user name for their name, but we want to ask them for their first name, last name, email, and phone. All right? So you can pause the video now, work on this exercise, and then resume the video to look at the solution. Okay, let's look at the solution now. So I have to collect 4 details, so that means I need the input function 4 times. Now, when you have to work on an algorithm like this, you want to work on this one step at a time. Okay? So see if you can get the user's first name first, make sure it works, and then you can proceed to register their remaining details. Okay, so let's see how we can do this. I'm going to type in input, and I can phrase this question any way I want. So I'm going to say, what is your first name? I'll put a space in here so they have room to type. And I want to assign the response to a variable. Okay, so since this is first name, I can say first name using snake case. Okay? Now, before I attempt to do this for the other details, let me see if this one works first. So I'm going to say print first name, save it, hit play. What is your first name? Okay, it works. So the first one works. Okay, now what I can do is I can, use this statement that I've typed for the other details. So I'm going to put here last name, input, what is your last name? And then again for email, I'll use input, what is your email address? And then phone, input, what is your phone number? Again, the question or the string you put in here doesn't really matter. Okay, you want to make it helpful for the user, but that's not really going to change the outcome of your code. All right. So with these 4 input functions, I can prompt the user for a response, and every time they respond, the answer they give, which will be a string, will be put into temporary storage. And then here, since we are assigning variables, or rather we are assigning those values to these variables, we can always get them back from temporary storage. So I'm going to also repeat the print function for the other details. So print last name, print email, and print phone. I'm going to save that. Okay. And if this works, then we should be able to prompt them for all the details and print their details back. So I'm going to hit play, clear my console, type in my email, type in my first name, type in my last name, type in my email, and type in my number. So 050, for example, 1, 2, 3, 4, 6, 7. Okay. If I hit enter, I will have now saved all 4 pieces of data in temporary storage. And as soon as I enter, I'll jump to the next sequence of statements, which will print back all of the values that I have entered. There we go. That's really the solution to this exercise. And of course, I could have made it more user-friendly by putting another print statement here. Your details are, and then they would see the list of their details. Okay, so I'm gonna do this again. Just like that. That's the solution to this exercise. Now let's come to section 3. To talk about variables and strings, we just want to look at some features of Python. If you remember, we had the print function from earlier, and we said that the print function takes an input, which we call an argument, and we had the message, hello world. We call this entire thing a string, and more specifically a string literal. Now this literal word we'll come back to later on, but basically it's a string, or rather a sequence of characters contained within quotation marks. Now if you remember, we said that double quotes or double quotation marks or single quotation marks doesn't make a difference, they are interchangeable. But when we put a sequence of alphanumeric characters together, wrapped inside quotation marks, we call this a string literal. There are also number literals, which we will look at later on. But yes, we pass this string as an argument to this print function. What does a print function do? Well, we saw that in VS Code, when you run this line of code, the integrated terminal opens up and your message appears in there. Now let's add a line here and declare a variable. Let's call this variable arbitrarily message. And we will assign hello world to the variable message. What happens if we type in here message now? Well, the same thing will happen. If you run this, we still get hello world. So what's going on in here? Well, we said that when you create a value or create a piece of data, when you create a piece of data, it will be written into memory. Using a variable, we can point to that piece of data. And then once we have a variable that is pointing to that piece of data, we can retrieve it whenever we want, as many times as we want. So when Python runs this line, it will point this variable to this string. And then the next line, when it sees a print function and this message, it will identify this as a variable. And it will go to that line where the variable was assigned a value. And it will find that the value was in fact hello world. Okay? Let's look at something that is related to this. Say we have another variable. We'll call this price. This, by the way, is a number literal. and more specifically an integer literal. You can see it is a sequence of numbers which together form an integer. And an integer is a whole number that is signed, meaning it can be positive or negative. But there are no fractions involved. There's no decimal point involved. If you put a decimal point and some more numbers, this then becomes a float, not an integer. But we will return to numbers later on. So we have this price, whose value is 1,000. And here we want to type in the print function. And we will say 1,000 plus price. What do you think will be the return value? Or what do you think will be the result of this evaluation? Here we have a string, and here we have a variable called price, which of course has value 1,000. So we are adding the string 1,000, or rather the string 1000, to the number 1,000. What will this expression evaluate to? Well, let's hit run and see. Let's play this and see what happens. You can see here that Python throws an error. It says can only concatenate. The word concatenate means to put two things together. Can only concatenate string to string, not an integer. Python is complaining about the different data types that we're looking at here. We are not able to add a number to something that is not a number. This plus sign, by the way, can be used for two things. For adding two numbers together or to concatenate two strings together. What does it mean to concatenate? Well, so we can't run this line. Let me make a small modification up here. And I will wrap this sequence of numbers inside quotation marks. So now this goes from being an integer to being a string. What happens now if you hit play? Well, let's find out. If you look closely, let's do that one more time. We have 1,000 and 1,000. Note that this is not the sum of two numbers, but simply two strings glued together. This is what we mean by concatenation. When you glue two strings together, that is what we call concatenation. This is what I mean when I say that the plus sign can be used for two purposes. Either adding two numbers together or concatenating two strings together. In this case, in this scenario, we have a string and we have a variable whose value is a string. So since we have two data types that are, well, of the same data type, this expression will work. But if we go back to having an integer, and of course removing these quotation marks, so converting this from a string to an integer, well, now we have two integers in this expression. Now the plus sign will add, it will function as a arithmetic operation. So we'll get 1,000 plus 1,000, which of course gives us 2,000. So the point of this exercise is to make you aware of data types. You cannot mix them. Now there is a way where you can include a number next to a string if that's your intention, but that is what is called casting. We'll look at that in a second, but you just need to remember that you need to be careful when you're working with your data types. If your intention is to add two numbers together, as in perform an arithmetic operation, then you need to make sure that those numbers are in fact integers and not strings. Okay. And let's bring back the old example. So this is example 1. This is example 2. Okay. And of course, we can't do this because that is a string, that is a number. You cannot mix data types. Okay, what you can do, however, is cast. So if you want to cast, that means you want to convert this to a different data type. We can use the integer function. This will turn, well, this sequence of numbers to an actual integer. Okay. So if you run all three, this will give us 2000. This will also give us 2000 because we have an integer plus another integer. And then, of course, this is just a string concatenation. So what we should see when we hit the play button is 2000, 2000, and 1000 next to 1000. There we go. Okay. So let's comment these out and leave some comments here. Adding two integers. This is casting to integer and adding. And then this is concatenating two strings. So now let's move on to section number 4. And talk about control statements. The first control statement that we'll look at is the if and else statement. Say we have two variables. Price equals 1000, budget equals 500. And let's say we have two print statements. Buy the product, and right after that, don't buy the product. We want to control this program so that either one of these print statements is processed, not both. We want either one of these to run, given the condition we have up here. So we have a budget, and we want to buy this product, or at least that's what we want to print, if the budget, or rather if the price, is within our budget. How do we make this happen? Well, using what we call an if and else statement. We type in the word if. You notice how it turns purple? That's a reserved keyword. We say if the price is equal to our budget, then we print the product. Else, don't buy the product. Now you want to pay attention to two things here. Number one, this is what we call our condition. And if you notice, I've put here two equal signs. This is not a mistake. This has a meaning. Two equal signs, that is what we call a comparison operator. So up here, if you notice, when we want to assign a value to a variable, we use one equal sign. So this is an assignment. This is an assignment. This, however, is a comparison. we're comparing, we are asking, are these two the same thing? Do they have the same values? Number 2, the indentation. So this is not just to make the code aesthetically more pleasing, although that's a good idea. The indentation indicates that this line of code will only run, this line of code would only run if the above statement is true. Whereas this line of code will only run if this statement is true. Let me make a comment in here very quickly. Let's say we have a few lines of code. Okay, imagine these are lines of code in Python. So the way Python will process this is sequentially. So it will run this line, and then this line, and then this line. Now find line number 5, and then the process is exited. And that is the end of the program. And all of these 5 lines are independent of each other. And unless your code breaks, let's say on line number 3, Python will continue to run lines 4 and 5. When you put indentation, when you press the tab key, and this is important, then you're saying to Python that this line of code is within the scope of this line number 2. This is what we call scope. When you indent, you are putting a statement inside the scope of another statement. So for example, let's say that this line, whatever it is, will only run if the line above it, which could be which is an if statement, is true. Okay? So you need to be very careful with that. And if you have multiple statements that will run, you need to make sure that they are perfectly aligned. Now you can use spaces to indicate the scope, so it doesn't have to be the tab key. So you can use, for example, 2 spaces, but you just need to make sure that you are consistent. So you don't want to have something like this. This is not clear. Okay, so whether you prefer to use the space key or the tab key, which is just quicker, you just want to make sure everything is perfectly aligned. So these 2 lines are within the scope of line number 2. In other words, these 2 lines would never run unless the line above them is true. And of course, we can have nesting. So line number 2 could be a block of code that is within the scope of line number 1. So these 4 lines go together. If this line is not true, let's say if it's an if statement. If this statement is not true, line number 2 will not run, and neither will lines number 3 and 4. Okay, so keep this indentation idea in mind because it's very important. And one more thing, in VS Code especially, you can use these gray lines, and sometimes they come in different colors, to help you find out to which scope any line of code belongs. So if you follow this gray line, we can see, yes, that these 2 lines are within the scope of line number 2. And line number 2 and all of its statements in turn are within the scope of line number 1. 5 and 6 are independent. All right. So here's how Python will process these 4 lines. It will process this line. It will go, okay, is price equal to budget? Let's see, price is 1,000, budget is 500. Are they equivalent? Well, they are not equivalent. Since they are not equivalent, this statement, which belongs to that if statement, will not be processed. So Python will skip this and then move on to the else statement. And we'll end up with don't bind a product. If you run this quickly, you'll see that is the case. It says don't bind a product. Now let me stop here to add another section because I'm sure you're thinking, well, what if we want to say that the price should be or less than or equal to our budget, not exactly equal. And what about the other conditional operators? So let's talk about the other operators. Let's come down here and create a new section for the operators. And they are as follows. So these are the operators in Python. Very quickly, let's go through these. That's the assignment operator. So if you want to assign a value to a variable, that's the operator you will use. The comparison operator, which we said is used to compare two constructs together, let's say two numbers together or two strings together. Of course, we have the arithmetic operators, addition, subtraction, multiplication, division. The floor division operator will return 0 if the remainder is less than 1, and it will return 1 if the remainder is equal to or above 1. So if you want to find out if you want either 1 or 0 in your division operation, then that's the operator you will use. If your remainder is less than 1, it will be rounded down to 0. So that's two forward slashes. We have exponentiations. If you want to raise a base to a number, then you can use two asterisk symbols. This is the not equal. So if you have this is the opposite of the comparison operator up here. So this will check if two things are equal. This will check to see if two things are not equal. Okay. Then we have the inequality comparison operators. So greater than, less than, greater than or equal, less than or equal. We then have the Boolean operators. We will look at an example of one of these in a moment. We have the modulo operator. This also has to do with remainders. We'll look at an example of this. And then increment and decrement. So if you want to increment some the value of some variable by let's say an increment of 5, then you can use plus or equal, and if you want to decrement it, obviously you can use minus and equal. So let's leave this list here. We'll make references to this table as we go along. Now let's come back up here to section 4. So right now our algorithm works, but what if we have a price of $4.99? Technically speaking, this is within our budget, but when we run this program, it still says don't buy our product. Well, that's not what we want. We want it to be within our budget, not exactly equal. So what we can do is we can say if the price is less than or equal. So as long as the price does not exceed the budget, we want to buy the product. If we save this and hit run, sure enough, it says buy the product because the price is within our budget. Now let's look at an example that involves multiple conditions. And let's say we have a situation where we want to print the price of some product. And to keep this example simple enough, let's say we have 3 products. So we have the iPhone 13, the iPhone 12, and let's just put in here the Samsung S20. Okay. Now the prices could be very different when you're watching this video, but at the time of this recording, the iPhone, the prices of these products are, let's just say $829 for the iPhone 13, $699 for the iPhone 12, and $600 for the S20. So we want to write a little program that checks the name of the product. Let's say the user can enter the name of the product, and our program returns the price for that particular product. So here's how we do it. Let's create some space here. We have 3 products, which means we need to have 3 comparisons. So let's say the user's input, let's assume their selection is S20. So here's how we set up the statement, the control statement. If user input is equal to iPhone 13, then print its corresponding price, which is $8.29. Now this is a combination of else if. Let me type in the statement. Else if the user input is equal to iPhone 12, then print $6.99. But we're not done yet. Else if user input is equal to S20, then I'm going to print 600. Now, what if the user chooses something that is neither one of these options? Well, then we default to print not a valid option. Okay. Now, this is a very simple and crude price checking program. But the point of this exercise, again, is for us to become more familiar with Python and its programming constructs. So let's see how, let's look at what's going on in here. So we assume the user selects S20. Now, of course, we can program this, but let's assume this is what they select. And then Python will process this entire statement as follows. I will move here and we'll say, okay, is the user input equal to iPhone 13? Well, are these 2 equivalent? No, because the user chose S20 and S20 is not equal to iPhone 13, so we're not going to print this. And then we come down to 58, line 58. Let's see, is the user input equal to iPhone 12? No. Again, that's S20 and that's not S20. So we're not going to process this line. Then the third elif statement. Is the user input equal to S20? Oh yes, they're both identical. They're both the same. So then we're going to print 600. And if you run this, you can see it will run that statement and the program exits, the process exits, right? So only one of these lines could be processed. Only one of these 4. Now, if we had different characters in here, like a space, okay, that is still a character, and this sequence of characters is not identical to this sequence of characters. So if we were to run this, we would get not a valid option. So you need to be careful about that. When we make a comparison here, you have to be very explicit, and Python will compare them strictly. So if you type in here S20, as far as Python is concerned, these are 2 very different things. So ladder casing is important, and even spaces are important. Okay. How do we make it so that the user chooses the product so we don't hard code the result? Well, if you remember, we had the function input. So we can say enter product name. And if you want, we can tell the user what the possible options are to make it to slightly make the user experience better. Or we can see options. Okay. Let's say we have a very small e-commerce application. Now, of course, actual e-commerce websites are far more elaborate, but that's not what we're building here. We're just trying to see what control statements are, what they do, and how we can use them. So let's go ahead and run this. Let me clear the comments, clear the terminal. And I just noticed that I want to leave space for the user to type in their answer. So I'm just going to put a colon and put a space in here. Okay, and then let's hit play one more time. So these are our options: iPhone 13, iPhone 12, S20. I will type in the product. What about S21? Not a valid option, right? Because that is not programmed into our control statement. So let's run this again. iPhone, and of course I have to be careful with the spelling, the letter casing, and even any space that I put in here. So if I put an iPhone 12, $699. There you have it. So you can use a control statement, and in particular an if and else statement, to run either one of these print statements. Just make sure whenever you do put a statement underneath an if statement that you indent. Indentation is very important. Okay? If you move the print statement out here, then you're leaving the scope of the if statement, if you remember. So make sure you indent and everything is perfectly aligned. All right, let's work on an exercise and try to solve this exercise using what we have just learned about if and else statements. So this exercise is about writing a small program very similar to the example we just looked at, where we print the price of a coffee selection for one of these options. So we have, let me just indent this a little better. We have Americano, cappuccino, and latte, where the price is $5, $6, and $5 respectively. Okay, so using the input function, we can ask the user what coffee they want, and then we will take their response through a sequence of if and else statements, check their option, and then print the appropriate price. Okay. So now you can pause this video, work on the exercise, and then play back the video to see the solution. All right, let's look at the solution together. So we can use the same variable we used in the script. So we can say user selection. And before I put here the input function, let's just assume they want an Americano. Okay, so I'm going to make my program work for this specific example, and if I'm able to get the price of the Americano right when I run this script, then I will proceed to complete the exercise for the other options. Okay, so if you recall, in order to ask the user for their input, well, we use the input function, and here we can put the question, please enter coffee selection. Okay, but let's just assume they will respond with Americano. Remember, when you are working on an algorithm, try to create a very simple implementation and then gradually make it better and better. All right, let's see. The price of Americano is $5. So what we want to do is type in, or we want to run print $5. And we only want this to happen if the user selection is in fact Americano. So what do? We put in the F keyword, and then we want to use the comparison operator and check to see if it's an Americano. And then, of course, we shouldn't forget to indent, because after all, this line belongs to the scope of the above if statement. So what happens if we run, are we going to see the price or not? Well, we are, yes, because these two are exactly the same. Okay, so I was able to get it to work for this one option. All right. What would happen if I had spelled this differently? So let's say I had a typo in here. What's going to happen then? Nothing's going to happen. Nothing's going to happen because, well, we only have one print statement, which will run only if this condition is true. But what if we had, what if we want to tell the user they have entered an incorrect option? Well, that brings us to the else statement. So we'll say else print. Again, we can say not a valid option. Now, of course, I have not included this in the steps, but again, this is something you have to think about. What if the user asks for something that we don't have? Okay. Let's just make sure it works. I'm going to run this again. Now, I know that this program is going to work because it's a pretty simple program, but you want to make a habit of progressively building your solution. So don't try to write everything at once. Don't try to make the solution perfect and efficient and only test it at the end. Test it gradually. Okay? So far I was able to get my work to work. I was able to get my solution to work for this option. Okay. What if we had another option like cappuccino? If I hit play, of course it's going to say not a valid option, but it is a valid option. So how do we accommodate this? Well, using elif. So we say else if the user selection is equal to cappuccino, then we will print its corresponding price, which is 6 USD. Keep in mind the else statement must always come at the end. You always begin a sequence. You always begin an if and else control statement with an if statement, and you end with an else statement. This is not. If you exclude this, it will not break your code. But in this example, we definitely want it in there because we want the user to know that there's something wrong with their input. Let's run this to make sure it works. I expect to see $6, and in fact, I do see it. I do see it in there. Okay, what if I were to use the input function instead? So as opposed to hard coding the answer, let's interact with our program. So I'm going to hit play, and now I can enter a name here. So if you remember, we have only programmed our code to work for only these two options. So only one of them, either one of these two will give us a price. So if I type in cappuccino, it works. Okay. So long as I use the correct letter casing and the same spelling, it will work. Well, we have a third option, which is the latte. So let's bring in our third option. User selection equals latte. And then print 5 USD. Now, the order doesn't really matter. We don't have to put Americano at the top and cappuccino. There's, it could have been put in either order, but the else statement does of course have to come at the end. Now you notice here that Americano and latte have the same price. Could we have done something about this so we don't have to repeat ourselves? Yes, but let's not do that right now. Let's just make sure the solution works and then see how we can make it better. So I'm going to run this, make sure it works. If I type in Americano, That works. Run the program again. Let me type in something that doesn't exist, like Turkish. Yep, says not a valid option as expected. What if I type in Americano in all lowercase? Still doesn't work. Now, of course, in Python we have string. We have functions and methods for string that allow us to deal with the situation, but we'll get to that later on. Let's run it one more time. So let's see if we can get the price for latte. Yep, that works. So great. We have a solution. The solution works. And that's really the end of this exercise. Now, if you are curious to see how we could make this slightly better, for example, we make it so that we don't have to repeat ourselves, well, then we can use one of those operators that we talked about. Okay, so I'm going to copy this and I will type in OR and paste that. And I'm just going to get rid of these two lines altogether. So I'm saying to Python, if this comparison is true, or if this other comparison is true, then print $5. Let's run this. And again, I'm just going to hard code the answer so I don't have to type in the answer every time. And let's see if we get $5, if we get the same line, if either one of these conditions are true. So yes, it says $5. Yep, it says $5. And if I were to hard code latte in here, same thing. Now you might ask, well, would this work if we had a third condition? Yes, you could chain another condition by introducing a third operator. So let's say we had a fourth option. Our fourth option could be, let's put in Turkish coffee. So now we have three conditions. So if we have three products that have the same price, we could use OR. Now in practice, if you have a lot of products, you wouldn't use this. So this is useful if you have a very small number of options, like less than 10, let's say. If it grows any bigger than that, we have to look at a different approach. But for this small selection of items, this will do just fine. If you run this now, and let's say the user had selected Turkish, you can see it still says $5. Okay. So there you have it. That's the solution for this exercise.